Well, for the abelian anomaly, it can't. There are theorems that show that it won't affect it. As I said, for the non-abelian anomaly, everybody thinks the same is true, but I don't know that there's a genuine rock-solid proof of that. What happens if you add any other terms? You can add other terms to that thing. But remember, the condensate, there's a dimensionality to the condensate, which is expressed by that f pi squared, right? Q bar q is not a uniform quantity. It has dimensions. That's what the function of the f pi is. So anything else you add, so the argument goes, would be that is a function of the condensate, would be dimensional, and it'll be suppressed by powers of a mass-breaking scale. So you can do it, but unless that mass scale is very low energy, those other terms won't matter very much. But this one does matter comparable to the other one. In some sense, compared to that term, this is the most important. The hypothesis here is simply it's the kinetic energy of the condensate. What's the simplest thing any physical structure can do? Well, it has energy of motion, right? This is basically what that is. Relativistic. All right, so what I think I'll spend the rest of the time on, I won't get through all this, is this notion of an index theorem. So just to give you some introduction to some of the mathematics behind this, there was this notion that d star of J5, remember, we saw in the path integral derivation was twice the sum of phi n dagger gamma 5 phi n, and that was 0 times infinity, because the phi's gave a delta of x, but there was a trace of gamma 5. The phi's gave delta of x minus x, and the trace of gamma 5 gave 0. So when it was regulated, it gives us that, where f is equal to a half f nu dx nu wedge dx nu. That's what that f means. And upon integrating, what was pointed out a couple of days ago is this is equal to that. I'm tracing over all these are solutions to d slash phi n in lambda n phi n. So I'm tracing over all the Dirachology that is in here. But there is a completeness rule. Because of the trace, I can pull this around to the front and use the fact, I guess I'll have to write it down, that the sum well, it's implicitly over everything you can trace over the Dirac indices, the function. Let me just write down what I was going to write down. Phi n of x, phi n, this is delta of x minus y. So because of this trace, I can pull this around to the front and use that on the delta of x minus x, which is delta of 0 times, if I put in the Dirac indices, this is a, delta. Right? So then that's what gives me the trace of just gamma 5 by itself. Is that? Nope. Okay, so what is an index? The index of an operator O is defined as the number of positive chirality or helicity or duality solutions, n of O plus and minus equals number of plus or minus duality solutions to O acting on some field phi equals 0. They're the number of zero eigenvalue solutions to an equation, to the eigenvalue equation for O, where these are defined on some manifold M. A form or some kind of field defined on a manifold M. That's what phi would be. So in this context, phi would be a Dirac field. But you could imagine, in fact, let's give examples. Maybe I'll write it over here. Examples. Phi could be given by psi, and then we'll have psi plus or minus is a half 1 plus or minus gamma 5 acting on psi. I could call this phi plus or minus if I wanted to, or more generally, I don't have to be gamma 5 dimensions. I could be in 2n plus 1. I could be in 2n dimensions. So this is the chirality operator, gamma 2n plus 1. Gamma 2n plus 1 acting on psi plus or minus is plus or minus psi plus or minus. So the eigenstates of gamma 2n plus 1, gamma 5 in the real world, is tell us whether you've got positive or negative chirality. And we have orthogonality in that psi plus, excuse me, psi plus bar psi minus is psi bar minus psi plus, and that's 0. Psi bar left, psi bar right is 0, and vice versa. Well, I'm going to try and give a more general definition in a moment, but as an example, it would mean this in this context. It would mean, here's another example before I get to what you're thinking is. So another example would be the gauge field strength itself. I can write it as F mu nu plus or minus F dual mu nu, where F dual mu nu, remember, I think is a half epsilon mu nu alpha beta F alpha beta.